MCV4U1 Chapter 1, Lesson 15. In this session, we are going to work on limit of f of x as x approaches infinity. Let's start with a couple of examples. What is limit of 2x plus 1 as x approaches infinity? When x approaches positive infinity, 2x plus 1 approaches positive infinity. When x is getting bigger and bigger, 2x plus 1 is getting bigger and bigger. Limit of minus 3x plus 1 as x approaches negative infinity. When x approaches negative infinity, negative 3x is positive infinity. Therefore, negative 3x plus 1 approaches positive infinity. By looking at the graph of f of x, let's find limit of f of x as x approaches negative infinity. When x approaches negative infinity, y approaches negative infinity. And when x approaches positive infinity, f of x approaches positive infinity. Limit of 1 over x as x approaches positive infinity is 0. When x is getting bigger and bigger, 1 over x is getting closer and closer to 0. This is the graph of 1 over x, and from the graph we can verify the limit of 1 over x as x approaches positive or negative infinity is 0. Let's find limit of 2x plus 3 divided by 3x plus 2 as x approaches positive infinity. To find this limit, we divide both the numerator and the denominator of the fraction by x. The limit would be the same as limit of 2 plus 3x plus 3 over 2x as x approaches infinity. Since limit of 1 over x as x approaches infinity is 0, the numerator approaches 2 and the denominator approaches 3 when x approaches infinity. This means limit of 2x plus 3 divided by 3x plus 2 as x approaches positive infinity is 2 over 3. Limit of x5 over x3 plus 1 as x approaches negative infinity. If we divide both the numerator and the denominator of the function by x to the power of 3, the limit would be the same as limit of x2 over 1 plus x3 as x approaches negative infinity. When x approaches negative infinity, the numerator approaches positive infinity. The limit of x2 as x approaches negative infinity is positive infinity. And the limit of 1 over x3 as x approaches infinity is 0. Therefore, the limit would be positive infinity. Generally speaking, limit of a polynomial as x approaches infinity is the same as limit of its dominant term as x approaches infinity. For example, limit of minus 5x3 plus 3x2 plus 7x plus 9 as x approaches infinity is the same as a limit of negative 5x3 as x approaches infinity. To prove this, we can factor x3 and use the fact that limit of 3 over x as x approaches infinity is the same as limit of 7 over x2 as x approaches infinity. It's the same as limit of 9 over x3 as x approaches infinity, and it is 0. Using this fact, we can say limit of 2x2 plus 3x plus 5 divided by 3x2 plus 7x plus 1 as x approaches infinity is 2 over 3. Because this limit is the same as limit of 2x2 divided by 3x2, the dominant terms of the numerator divided by the dominant terms of the denominator, which is 2 over 3. Limit of x5 over 2x3 plus 7x plus 1 as x approaches negative infinity is the same as limit of x5 over 2x3 as x approaches negative infinity, which is the same as limit of x2 over 2 as x approaches negative infinity. And this limit is positive infinity. Limit of 7x over x2 plus 11x plus 4 as x approaches infinity is the same as limit of 7x divided by x2, which is the same as limit of 7 over x as x approaches infinity. And this limit is 0. Thanks for watching.